We're going to start looking at absolute value functions. Okay, we're going to start by looking at a t-table here. This is the basic absolute value function. So we're going to say y is equal to the absolute value of x. We're just going to graph that parent function. Okay, so we're going to look at some t-tables. So for some values for x, we're going to look at values like -3, -2, -1, 0, 1, and 2. Okay, we know absolute value means distance away from 0, so the absolute value of -3 is 3, the absolute value of -2 is 2, -1 is 1, absolute value of 0 is 0, and absolute value of 1 is 1, and 2 is 2. Okay, and if I plot these points, I'm going to go -3 up 3, -2 up 2, -1 up 0, 0, 0, okay, 1, 1, 2, 2, and I could also plot 3, 3 down here, okay, 3, 3. So you're going to notice that there's two pieces to this graph. This is a linear equation positive, and this is a linear equation negative. This is also an example of what's called a piecewise function. It is a function. It passes the function test, but it's also piecewise. Okay, so this is your basic parent function of what an absolute value graph looks like. It starts at 0, 0, so key points of information here. Okay, it starts at 0, 0. It has a slope of up 1 over 1 to the right, and it has a slope of -1 to the left. Okay, so now we're going to start taking these graphs and we're going to do what's called a translation. Okay, let's define exactly what a translation is. Okay, a translation is a shift of a graph that is horizontal, vertical, or both. Okay, so we're going to just start off looking at vertical graphs in this video, then we're going to look at horizontal, and then we'll look at when we combine them together. Okay, so if I started off with y equals the absolute value of x graph, okay, from the last video we knew, from the last screen I have an absolute value graph looks like this, okay, and then I'm going to go to the left. Okay, so now let's take this same graph and say y is equal to the absolute value of x minus 2. Okay, so that's going to take all these points and I'm going to go down 2 with it. 1, 2, down 2, take this point down 2, down 2. Okay, and you'll see that it results in a graph that looks like that. Okay, so that is what's called a vertical translation. So let's kind of describe what happens with vertical translations. So if I started off with a graph that looks like this right here, okay, this has a vertical translation of 3. So I'd say that this is y equals the absolute value of x plus 3. Okay, if I started here, it'd be plus 2, plus 1, minus 1, and so on. All right, so to summarize here, we're going to say if we have y equals the absolute value of x plus k, and we're going to say k, if k is a positive number, if k is a positive number, if it's a positive number, then it translates. Another word for translate is slide. It translates up k units. Okay, so if k is a negative number, then it translates down k units. Okay, so something like down here. Okay, this would be the graph of y equals absolute value of x subtract 2 because I went down 2 units. Okay, now horizontal translations aren't quite as easy as vertical translation. So horizontal translations kind of have a surprise, and it's kind of the reverse of what you might think. So I'm going to show you why. So we're going to look at the graph of y equals the absolute value of x. Okay, and I'm going to graph that one in blue to start with. Okay, and then I'm going to look at the graph here of y equals the absolute value of x plus 2. Okay, I'm going to take my x values and I'm going to make a t-table. So if I plug negative 2 in, then I get 0. So I'll plot the point negative 2, 0. Okay, if I plug negative 1 in, I get negative 1 plus 2, which is negative 1. Absolute value is 1. So negative 1 up 1. Okay, if I plug in 0, I get 2. So 0, 2. If I plug in 3, I get 5. Okay, and we can see right now, if I'm at 3, I'm up 1, 2, 3, 4, 5 right there. Okay, so we can see this half of the graph is going on. All right, so now what's going to happen, if I want to get over to here, I might have to do negative 3. So that gives me absolute value of negative 1, which is 1. So negative 3 up 1. Okay, at negative 4, I'm up 2. Okay, so that's going to be the graph here. All right, so now when we go to look at this, what really happened to this graph? I started with blue, and it says plus 2. So I'm taking the graph and I'm going plus 2. But in the end, I end up going, I'm moving left 2. Okay, so notice how this just moved the graph to the left 2 spots. Okay, so now if I look at the graph, let's do another color. Let's try the graph of y equals the absolute value of x minus 2. Okay, so if that's the case, I'm going to do the exact same thing. X, let's start at negative 2, so that's going to give me a 4. If I start at negative 1, that's going to give me a 3. If I plug in 0, it's going to give me a 2. If I plug in a 1, it's going to give me a 1. If I plug in 2, it's going to give me 0. So if I plot those points, negative 2 up 4, negative 1 up 3, 0 up 2, 1, 1, 2, 0. So I might want to see what's going on at 3. So 3 minus 2 is 1. So 3 up 1. Okay, so now I end up with a graph like this. Okay, now I had a minus 2. I had a minus 2 right here, and that resulted in I moved right 2. Okay, so right 2. So basically, the horizontal shifts are the opposite of what you might think. If there's a positive, then you're going to go left, and then if there's a negative, you're going to go right. Okay, so let's kind of, at this point, put together actually I'm going to make a new video for the next one.